What is the biosphere? It is a simulation of the conditions before the worldwide flood. It is a huge tank chamber, 64 feet long, weighs 92,000 pounds. The inner chamber is 48 feet, and then we had 14 feet overlapping beyond that. It's 10.5 feet wide. In there, we will be simulating the additional atmospheric pressure, the additional oxygen ratio, the conditions before the worldwide flood. But we needed someone special who could complete it with us and who could automate it, because we had already built one manually, one that runs by manual operation, a smaller one. So we knew how to do all of that, but we needed someone to help us complete that, particularly in a way that would phase into automation. Well, God sent us a special man. He was 26 years with NASA. 24 of those years, he ran his own lab under the John Glenn Research Center auspices. In that lab, the larger portion of hardware in space had to be checked out. Well, this was this man's lab. He was awarded the Silver Snoopy Award. I like that name. Everybody knows who Snoopy was. The Silver Snoopy Award is awarded to less than 1% of the echelon of NASA employees. They have to do something absolutely astounding to get that. Well, he was awarded that. He and his wife have now moved to Glen Rose, will be spending essentially the rest of their life as he leads us. He's the lead engineer on the biosphere, to complete the biosphere, to add components, and he's going to take a few minutes and tell you how far we've come in this short time. This is NASA engineer Michael Hurlacher. Mike, you're home.
Thank you, sir. Good afternoon, ladies and gentlemen. True, 26 years at NASA, 20 years before that was an Air Force career, and then maybe 5 years before that, it was tinkering with electronics at home, much to my mother's chagrin, taking apart things. And I'm still doing that, taking apart, and hopefully with this biosphere, I'll be putting them together. So we moved down here about 2 months ago, and we've kind of gone through the resident equipment, the tank, and the environment, the atmospheric environmental equipment that we're going to process to put the right mixture of oxygen and nitrogen and carbon dioxide into the chamber. So that takes a lot of equipment to do. So I've kind of opened up the hood to all our equipment, taken off the covers, done an inventory of the internals. We've hired on a CAD drawer to make official professional drawings of what we have. And then on them, I've already started with my red pencil saying, this looks like a good place for an automation piece. This looks like a good place for a control valve. So we're at that stage right now, the conceptual design, to make sure that we operate the biosphere's atmosphere, like what we breathe out here, properly on the inside. So that's the main job that I'm going to be doing, is just making sure that that equipment works properly, operates, monitored, and that we record all that information. So when we show our biological results of this grass is growing faster, it has more nutrition, or this what used to be a little gecko is now a little bit longer than it should be according to today's standards, that we can tell the folks that, well, this is the environment that we had them in. And speaking of that environment, there's many different components of an environment. For example, the pressure, not just the oxygen content. Also, the lighting. Lighting's very important, especially for plants. They need a certain wavelength of light, color of light. You know, when you go and you buy a light bulb, it'll have like a color rating on it. Could be a little bit more natural, like red or yellow, and some are blue. Well, that light environment is also a part of what we need to control in there. So we'll have several different types of bulbs, LEDs, and we'll turn some on, off in a certain ratio to try to simulate, again, the light environment. So we talked about the air, and we talked about the light. We'll Okay, what about the temperature? How warm was it back there before Noah's flood? Was this like, were we all in like a greenhouse and it was 82? It's kind of hot for me, 82. So it's probably down in the 70s, and our scientists have postulated what that will be, and we'll also simulate the temperature. So we'll be adding equipment in there that will pull out some of this processed oxygen-enriched environment and go through a heater/cooler, depending on if we need to raise the temperature inside or lower the temperature inside. We'll also add a humidity injector. So you know how dry the air is down here, and it's always affecting your sinuses and whatnot. Well, we'll probably have to pump that up. Probably not necessarily to what the South America rainforest is, but at least up to a particular part where plants can live and the vapors won't be pulled out of their leaves and whatnot. And then we'll also control another aspect, magnetic fields. Oh, what's that? Okay, the Earth has a huge magnetic field around it. We all live in it. We're a part of it. We're in tune with it. And it probably influences our biology as well. So our magnetic field, as the doctor will tell you later in his lecture, has been changing over time. I'm not going to steal from his thunder to show how that is, but we're going to try to simulate what it was back when, because we have a feeling that that also will influence how things grew and lived back in the day. So we're getting more professional with this. We've got ideas on how we're going to control it with sensors, run it into a computer. It'll monitor, adjust flow, temperature, lighting, and we'll try to simulate a day and maybe even seasonal. And of course, the biologist will tell me all that, and I'll make my computer do just that. So have we covered all the bases? One other thing that we're going to do is when we might have humans going inside, maybe not at the beginning, but somebody will need to tend to these experiments. So to have humans go into an environment such as that, we're going to need 2 independent power sources. You know, if the Edison power that comes in here, we have a storm and it gets interrupted, we're going to need power in there, electrical power. So we're going to try to put in a UPS system, and that's not a delivery truck, that's uninterruptible power system. And for those of you that have a critical computer or something, and you never want it to go offline, that's what you put. It's a little battery pack, and it provides the power that your computer will need while the commercial power is offline. So we're going to try to install one of those as well as time goes on, as we phase it in. Any other questions?
You've
sir?
done it.
Okay.
You've done it. Let's give a hand to Mike Hurlacher. He and his dear wife, Bea, now live here. In the biosphere, we will be simulating conditions on the Earth and conditions that affected and do affect the Earth. For instance, one of the things I'll be covering in a few minutes in the lecture is the fact that the pulsars, star bodies out in space, actually transmit radio signals. There is sound coming on those radio signals. Dr. Frella Terenzi got her PhD in astronomy by using our plasma receptors in New Mexico, and in so doing, she was able to record those sounds. Those sounds affect us. And not only do those sounds affect us, but the moon originally was covered with a whitish yellow substance. I've actually held some of that substance from NASA. It is now available commercially. We're going to bring a large tray of that here so you can see it and hands-on experience it. We already have the connection as soon as it's available in the United States. Originally, the moon reflected the light of the sun. The moon does not have its own generate its own light, but the reflected light of the sun, that's a picture of the believer. We reflect the light of the Son, Jesus Christ. So my question was with David Bassett, please name that substance that was and is on the surface of the moon, and what that substance does, and how it was brighter and why it was brighter before the flood that created a lot of problems for us. What is that substance? How bright would it have been according to the research of most creation scholars?
The substance is the northite. The Creation Research Society published in their journal a few years ago that it would have been about 7 to 10 times brighter, which is the reflectivity called the albedo, how the sun's light reflects off the moon's surface. We're all familiar with the man in the moon when we see it up there in the full moon phase, and we see those dark kind of grayish patches that are up there. Those would not have been there, we presume, on day 4 when the moon was new. That's erupted material that has come out from inside the moon to spray over its surface and basically dim the moon. So before that actually happens, the moon would have been much brighter. Because the moon is slightly receding away from the Earth due to tidal effects, the moon would have been closer to us at that time, which makes it even larger there. And so we would expect a much brighter, bigger moon before the flood.
All
So
right.
that's basically the summary of that.
And that substance again is,
It's a northite.
and it is related to a northocite, which is a derivative.
Correct. A northocite believes the mineral. A northite is the rock. And it's the actual original moon material.
Yes.
So.
Well done. Thank you. Let's give a hand to David Bassett.